Hello friends, today we are going to learn optimal storage on Dept. So learning outcome for this session is students will be able to apply greedy method to find permutation of programs so that mean retrieval time, that is MRT, is minimized. So what is optimal storage on tapes problem? So there are n programs that are to be stored on the tape of length L. So program I has length Li and the number of programs are n. So these programs are stored in order I1, I2 dash dash In, and the time Tj is needed to retrieve the program Ij, which is proportional to the length of the program. Now what do you mean by this? So here this is a single tape. The tape head will be always at the start, and when we want to retrieve the third program or read the third program, we need to read the first program completely, followed by the second program, and then we can retrieve the third program. So what is the time required to retrieve the third program is nothing but L1 plus L2 plus L3, or for fourth program it will be L1 plus L2 plus L3 plus L4. So here the time Tj is nothing but the time required to retrieve the program J. So length is nothing but from 1 to J. So if all the programs are retrieved oftenly, then expected or mean retrieval time is nothing but addition of all the times divided by n. This is called as a mean retrieval time. And the objective to find the permutation for n program so that mean retrieval time is minimized. So objective function is of minimization of the time. So here MRT is equivalent to minimizing this double summation of length of each program. So this first summation is for retrieving the program, and the second summation is for addition of all the programs. So now let us consider we are having 3 programs and the length of the program is 5, 10 and 3. So for these 3 programs, so how many orderings are possible? So at this moment, pause the video and write down all possible orderings for 3 programs. So I hope you have written the orderings. So possible solutions or the orderings are n factorial. So in this case it is going to be 3 factorial or 6 orderings. Now what do you mean by this ordering is that 1, 2, 3. So first program followed by second and followed by third. Next combination is 1, 3, 2 or 2, 1, 3. Then 2, 3, 1, 3, 1, 2 and 3, 2, 1. So these are the 6 possible orderings. Now we will see how much time is required for each ordering. So consider if the programs are stored in the order of 1, 2, 3, the time required to read the first program will be length of the first program, which is 5. The time required to retrieve the second program is length of the first program and length of the second program, which is nothing but 5 plus 10. And the time required to retrieve the third program is 1 plus 2 plus 3 or 5 plus 10 plus 3. 1 plus 2 plus 3 is nothing but length of the first program, length of the second program and length of the third program. So total time required is 38. If we will go for this 2, 3, 1, the time required for second program is 10. So time required for this third program will be 10 plus 3 and time required for the first program will be 10 plus 3 plus 5. So total time is 41. So in this manner we have calculated this times for every combination. So 38, 31, 43, 41, 29 and 34. So which is the minimum time that we have found? So divide by 3 because we are finding its average, and then we have found that the optimal solution is 9.66. So if we will store the program in the ordering of 3, 1, 2, we are getting this D of I is 29 or MRT as 9.66. So this is the minimum time that we are going to get. So what is the approach to obtain this optimal solution? So what the approach that we have seen first? Find all the permutations of the program and find the optimal solution, which is nothing but minimum MRT. So but what is the drawback of this method is that for the large value of n, the value of n factorial will be big. So writing all the possible solutions and finding the minimum of this is going to be the time consuming task. So can you think what can be the other approach which will save your time? So yes, greedy approach to obtain the solution. So if you have observed which ordering you have given the optimal solution. So it is nothing but store the programs in the increasing order of their lengths using any sorting order technique. Now you know what is the time required for sorting technique is nothing but n log n. So that is, in given example, increasing order of the lengths are 3, 5 and 10, and then we have seen that this is ordering 3, 1, 2 and the time required is always less. So the approach is that arrange it in increasing order of the length and then find out its MRT. Now we will prove this with using one theorem. So consider that we have stored all the programs in the increasing order of the length. So L1 less than or equal to L2 dash dash less than or equal to Ln, and ordering is Ij is equal to J. So which is nothing but here 1, 2, 3, which is indexed. So which will always minimize MRT over all the possible permutations. This is the theorem. Now we will say its proof. Now consider this I1, I2 dash dash In be the permutation of index set, which is nothing but 1, 2 dash dash n. Then how to find its total time required? We have already seen the formula. Now this is nothing but summation of n minus k plus 1 into Lik. What does it mean? That if we'll consider any ordering, the first program is going to be read n minus 1 plus 1, that is n times first program. How many times the second program will be read? N minus 2 plus 1, that is nothing but n minus 2 times, n minus 1 time, and so on. Now this is for first permutation where we have stored the programs in the increasing order. Now consider there is one other permutation where the program is stored such a way that A is less than B and its length is greater than the bth program. So interchanging the values of IA and IB, we will get the permutation I. Now this, what do you mean by this I dash permutation is that the ordering is such that they are not in increasing order of the length. If it is so, how to find its MRT? So here the formula is, except the programs where length is interchanged, you consider the summation. So k is equal to 1 to n and k is not equal to A and k is not equal to B, because this order is changed. So how many times it is going to be read? So it is n minus A plus 1 into Lib plus n minus B in plus 1 into Lia. Now this is what we have got, d of I and d of I dash. Now subtract this d of I from d of I dash, and what we will get, the subtraction is that B minus A into Lia minus Lib. Now B is already the greater than A, and second thing is that the length of A program is greater than length of B. So obviously this value is greater than 0. Now what do I mean by this is that the time required for I dash permutation is greater than the time required for I. And what is I? Where we have stored all the programs in increasing order of the length. So this is what the proof is. Now we'll see this with example. So consider n is equal to 4 and length are 2, 5, 8, 4. Now you know that how to get the greedy, how to store the program. So find the permutation I where they are in increasing order of the length, and any other permutation I dash where two programs are not in increasing order. So at this moment, pause the video and write down that two combinations. So yes, I is nothing but increasing order of the length. So 4, 5, 8 and 12. So which is nothing but 1, 2, 3, 4. In the second permutation, again, what is the ordering 1, 2, 3, 4? So here I have taken one combination where this A is less than B. So 2 is less than B. But the length of the program A is greater than length of the program B. So this is other combination. Now using the equation 1, we will calculate the D of I, which is nothing but 59. And using the equation 2, where we have interchanged the length, we are finding the value which is nothing but 62. Now take the subtraction of this 2 and we are getting the more time for this permutation, because here one program of having length greater is stored first than the other. Now using the equation number 3, which is we have used in the proof, directly you can calculate d of I dash minus d of I is equal to 3 minus 2 into 8 minus 3, which is again giving you same as 3. So this is the proof that if we'll take any other combination where the lengths are not stored in increasing order, the time required is greater. So what is the greedy approach is that always store the program in its increasing order to get the minimum retrieval time. So this is your reference. Thank you.